I will briefly give you a short introduction about the relevance of energy storage, especially here the battery energy storage systems. So the battery manufacturing industry is committed to contribute to the goals of the Commission to deploy the decarbonization and reliable energy system. So it's about 69% renewable energy share in 2030, and it will increase to 80% by 2050. The energy storage plays a crucial role in the current and future energy system. It increases the efficiency and security of energy supply while providing flexibility, stability, and reliability. So especially we see the battery energy storage system as a recognized and a major flexibility provider to develop a stable and a reliable energy system. We know as battery manufacturers that battery energy storage systems increase the efficiency and maximize the output of the installed variable renewable energy systems generation in the system. So battery energy systems are highly standardized products and they can be installed very fast and very quickly. They are on the one hand safe, environmental friendly, and we have shown already the highly recyclability of such kind of system. The diversity of battery energy storage system technology makes them suitable for many grid functionalities as well as to allow consumer energy management. So the development of the European community and the world energy storage market, and we see a main share by the utility scale battery energy storage system. So the capacity is expected to expand 44-fold between 2021 and 2030, reaching 680 gigawatt. This means 80 gigawatt annual growth rate. So the drivers in Europe are on the one hand the Green Deal and the Repower Europe action plan. The different battery energy storage technology in the energy systems, they are needed. We have different kind of performance data, so they serve also different applications efficiently, short and long duration energy storage. To support on the one hand the charging infrastructure, helping to deploy also the electric vehicle and hybrid electric vehicles and other clean transportation modes. And on the other hand, we have to distress the raw material supply chain towards Europe. We as a battery manufacturers will provide evidence on upscaling the European production capacities to meet future European and worldwide demand. Info and case studies to show we can deliver real and concrete technical solutions that work, whether located in front or behind the meter. This is somehow the most important messages, and I think we go more in detail now with our keynote speakers and our EUROBAT members.
Indeed. Thank you very much, Bernard, for setting the scene here. And without further ado, I'd like to move now to our next speaker. And actually, she's also the keynote speaker of today. I'd like to introduce Ilka van Dalwijk, who is the policy manager at EIT InnoEnergy. Ilka, the floor is yours. Thank you.
Thank you very much. I'm talking to you today from a conference in Amsterdam. I apologize already ahead of my presentation for any background noise. I hope it will work. It's actually about battery raw materials, so very timely. But without further ado, I want to start my presentation. Do you see the first slide, or does this internet clicker not work? Here we go. So today I represent the European Battery Alliance. It's the first industrial alliance that was launched back in 2017 by the European Commission with the objective to establish a sustainable and resilient battery industry in Europe. By that time, we already saw trends on the electrification, especially in the transport sector, and the risk of losing jobs and wealth if we would not try to master both the battery production and the transformation into electric vehicles, mainly at that time. So what we did was bringing together stakeholders along the entire battery value chain, trying to figure out concrete measures on how to kickstart the development of a battery ecosystem in Europe. And I think a lot has happened in those 6 years now that we have been active. And here we go. What we predicted back in 2017 was a so-called hockey stick, an uptake of electric vehicles that we forecasted to occur in 2020. And looking back, I think we have more than fulfilled this forecast. It's actually doubled the prediction back from 2017. So the uptake of EVs has been really been tremendously growing in Europe. Many car makers have announced plans to go zero emission free. The same can be said for the stationary storage market, that when we started was not the main focus of our activities, but there are the predictions, and in reality those markets quadrupled in those years that we have been active, which is a very promising development, I would say. Today, we still see that the main driver for the demand in batteries in Europe is coming from the EV sectors. There on the right-hand side, you see a lot of industrial commitments that many of the European OEMs have announced to go all electric. They're stopping plans to develop plug-in hybrids even. They will no longer develop any combustion engines. So I think we are on a good way to actually go on a right path. There are still a lot of challenges left. The European Union is not a uniform business region, so the uptake, of course, is driven by some countries more than others, and also connected to BNP. So right now, what we see, we will need a lot more focus on so-called affordable EVs, even if we have reached this mythical price parity between EVs and ICE cars, especially in the premium segment. I think what Europe is really needing for mass adoption of electric vehicles will be in the smaller segments. Another topic that is coming up is charging access to charging infrastructure and vehicle-to-grid solutions that are also seeing here a number of new business alliances that are tackling this issue. All of it is supported by a good framework of different policies. So Europe is creating this market demand by different measures. I think Erwin already mentioned the Repower for EU, but there are a lot of others targets and binding targets or visions that are set up also on a member state or even city level. Low emission zones like here in Amsterdam, where I'm now, that are only allowing, for example, EV taxis to drive from and to the airport. They are all pushing this market forward. There are also other applications coming along. Apart from stationary storage, we have also aviation and marine vessels that are looking to go electric. So all of this, of course, will spur the demand for batteries. But I think the most critical area is really grid storage, where batteries really can be beneficial for introducing a lot more also of the renewable energy. And I think we will hear more about it from Eurelectric later. We did look at market forecasts and try to analyze what we're seeing also by talking to a lot of our stakeholders, and actually came to the quite large number of an accumulated stationary battery market of 1 terawatt hour, that if you translate it into battery demand will top up to more than 2030, 200 gigawatt hours on top of what we currently expect in demand for EVs. This is a forecast that is based on industrial strategies, mainly on the EV sectors, and having a 15% on top of the other sectors like heavy-duty vehicles, buses, industrial machinery. But on top of that, we will also now see a quite positive development in the stationary storage ecosystem. But going forward and looking at a more global perspective on what is happening right now, I think all of you have heard of the Inflation Reduction Act, US biggest climate bill that was passed on 16th of October 2020. And this piece of legislation is really standing on three legs, you could say. It's tax incentives for production, tax incentives for consumers, and coupled to this also domestic requirements. And what we have seen in the ecosystem is that the project development and investors are really picking up on this trend. And there are many different nuances to this, but some of them I just wanted to talk about, and that is the cost of production for, in this case, battery packs, that thanks to the IRA incentives are now on a parity with production costs more or less comparable to China, which is one of the greatest competitors of Europe. And Europe is in even a worse situation than before due to the war on Ukraine, leading to higher energy costs. So production-wise, we are a little bit at a global disadvantage, but it also leads that the cost, that is something maybe not talked too much about, but also the levelized cost of electricity will be affected by the IRA quite significantly. And this is also due to that those credits, production credits, can go to the production of wind and solar. So you're making those products cheaper, you introduce them into the electric system, and all of this together combined will lead to quite tremendous price lowering of renewable energy. So this is something to watch out for as well as an effect of the IRA. Coming back to Europe, there are some attempts that we tried to counteract on investments leaving Europe. One of them is the temporary crisis and transition framework, which is a kind of relaxation of state aid. And the single market in Europe is our biggest asset, but sometimes also our biggest enemy. We do not want to distort the competition between the different countries that are richer or that are poorer, but looking at the urgency on what we see, that those project support that is needed in this short time frame really to ramp up projects, I think this temporary relaxation of state aids possibly helps bringing some of the projects off the ground. There are also others like the Critical Raw Material Act, looking at projects into refining, mining, recycling, setting up visionary targets on how much of those materials shall be produced in Europe or other countries that we have agreements with. The Net Zero Industry Act, likewise, also here ambitious targets, and combined with the Critical Raw Materials Act, also addressing the issue of permitting. And at that time means shortening permitting times for getting projects off the ground. Both of those proposed acts are not coupled to any financial incentives. There we will need to wait for the next financial framework period, and one of the instruments proposed there is a Strategic Technologies for Europe platform, the STEP program. It will not match the IRA in terms of financial support, but at least I think some of it can be helpful as well. The TCTF that I mentioned, here you have at least a couple of projects within stationary storage that have already benefited from it. It's a small beginning, and I think it's still quite promising that you see that things are moving in the right direction within Europe. And just coming to my conclusions. Electric transportation, I think it's still, we can agree on that the biggest driver that will drive the developments within the battery industry. Affordable cars is an imperative for getting mass adoption within the EV segment all across Europe. A lot can be done also in the design of batteries to improve their range as well. we see, and I believe that storage, stationary storage, is the next big thing coming around. We will see a similar growth that we have seen in EVs. Europe is picking up quite rapidly, even though the market in the US and in China are comparably still larger. But from a European perspective, I think there are good opportunities for new startups, also looking at the production focused on stationary storage solutions. This is mainly also driven on restrictions in the supply chain. I think everybody knows that the supply of critical raw materials, especially nickel, cobalt and lithium, they are constraining the industry. They are costly, so look out for new innovative technologies such as sodium ion, for example, that are better adapted for the needs of stationary storage as well. I think we will see very promising developments over there. Thank you very much.
Great, thank you so much, Ilka, for those opening words. And before announcing the next speaker, just quickly go back to the results of the poll question. So you can see that the big majority of the participants of the audience believe that LFP will be the dominant force, followed by the mainstream technologies, lead, nickel, and so on. And then we have the smaller ones below. Okay, great.
Yes, just as
ahead.
a response to this question, thank you. It was kind of expected to see this. And I just want to open up for that. There's still a lot of opportunities to develop, especially LFP projects in Europe, because currently what we are seeing is a lot of NMC. So we are lacking in LFP production in Europe. So that's a big, maybe an exclamation, not a question mark, but an exclamation mark on maybe getting this segment of the market going.
Duly noted. Thank you so much. Great. I'd like to move to our next speaker now. It's Aida Garcia, who is Advisory Renewables as well as 2030 Framework Lead at Eurelectric. Aida, the floor is yours.
Afternoon.
Thank you.
Good afternoon, everybody. It's a pleasure being with you today. I've been asked to present on how, yeah, the slides are there, perfect. Yeah, so I was asked to present on how we, the electricity sector, sees the role of storage in reaching our objective of decarbonizing the grids well before mid-century. I have to do this in less than 10 minutes, so it's quite a challenge. I was planning to first give you an outlook of the prospects of wind and solar in the coming decade. Then our projections for related storage needs that we see arising from these variable renewable capacities coming in, including, of course, stationary batteries. And finally, our policy requests to make this happen. So let's get started. What's the market outlook for wind and solar? If we follow REPowerEU, as you know, by 2030, we should triple the capacity of wind and solar to reach this 45% of renewable energy target. Now, this translates roughly into 70% of variable renewable penetration into the electricity mix, as was mentioned earlier in the opening remarks. And this is a tipping point, of course, where the flexibility needs increase exponentially for all the time frames, daily, monthly, seasonal. So overall, although there are very good prospects for wind and solar, this also comes with certain challenges, both market and technological challenges. For example, if you look at the right side of this presentation, there you may see some ENTSO-E projections for curtailments of renewables. And those, according to their projections, would reach 30% in several regions in Europe by 2030. And this, of course, results in lower utilization of wind and solar, less revenues for developers, and often higher emissions. Of course, there are solutions to this, and one of the most important ones it's boosting flexibility offerings, including storage. This brings me to the second slide. The second actually that you see now in screen. In our decarbonization pathways study, we modeled how much flexibility we will need to decarbonize the grid. By the way, those projections are in line with REPowerEU assumptions. And there we modeled that we would need around 100 terawatt hours well before 2050. And to put things in perspective, in 2022, battery storage reached only 9 gigawatt hours. This is less than 1% of what we need to decarbonize the grid. And just it reflects just how big is the gap between our needs and the current uptake of batteries. Within Eurelectric, we've also been reflecting on how to boost storage. And we've realized that Europe assumes that these projects will come to the market when needed, but a specific framework is lacking. And together with our members, we've been thinking about what should the European Union and member states do to make storage a key industry in the EU. There we kind of gather our requests into 5 main key policy actions. The first one is to consider storage as a flexibility option. For example, the electricity market design review, as soon as it's adopted, would mandate member states to carry out an economic assessment to better understand their flexibility needs and secure the most cost-efficient procurement. This is something that we support very much, and will make us more aware of where to direct the investments. Second, and I'd say it's the most important one, is to provide long-term predictability of revenues. Actions like the interventions in the electricity market design that we've seen recently are very detrimental for both renewables developers, but also for storage developers or any kind of investment. We should also implement the clean energy package, which already had very good provisions for this industry. Crucial is to facilitate capacity mechanisms and to properly remunerate all the services that storage provides to the grid in terms of flexibility, for example, in order to improve the business case. Finally, the classical request is do not task twice. Storage is a no-brainer, but still happening. And remove barriers to PPA market, as there's a lot of potential to have this multi-technology PPAs as a new income stream, or to secure this long-term revenue predictability for those projects. This brings me to the last part of my presentation, where we see that there's a need also to make an efficient use of existing funding opportunities for the transition. In particular, we are calling to member states, for member states to launch more tenders for co-located and standalone storage. Of course, all this in line with the EU competition rules, but there isn't auctions have been largely oversubscribed, so there's definitely an appetite for it. Finally, we should of course streamline permitting. This has been mentioned as well. There are very good provisions for both storage developers and manufacturers in the Renewable Energy Directive and the upcoming Net Zero Industry Act. Linked to permitting, connection access is quite an important topic as well. We consider that to avoid congestions, we should allow for flexible connection agreements, granting this early access to the grid in exchange of maybe a lower utilization rate, but granting this connection as soon as possible. And finally, of course, we are asking to ensure supply chain resilience. And in this respect, initiatives like the EU Battery Alliance, Critical Raw Materials Act, and Net Zero Industry Act, we believe are steps in the right direction. And yeah, with this, I would finalize my intervention. Just do not hesitate to get in touch. And yeah, we'd like to invite you to the launch of the Power Barometer tomorrow, where we'll discuss the latest trends of the electricity market, including storage. Thank you very much.
Thank you so much, Ms. Garcia, for those insights. Let's quickly have a look at the poll results. Clearly, a big majority, 80%, believe that less than 1% is indeed the correct answer, while 20% believe it's between 1 and 5%. Good. Let's now move to our first corporate speaker, and that would be Mr. André Haubroek, who is the Managing Director for the company Intellian. Mr. Haubroek, go ahead. Thank you.
Yes, thank you very much for getting the opportunity to give you a short introduction into what Intellian is doing and why we are empowering the world to integrate more renewable power in combination with ESS systems. So as you are quite aware of the grid infrastructure, so coming from a traditional energy system with a central power generation and a decentral consuming of the electrical energy, we see in these days and also in the long-term perspective more and more renewable power integrated into the grid, as well as more loads and more consumers can be seen in the grid. So that would mean we see more EV charging stations and more heating pumps in private households. We also can see that the industrial processes change from being gas-powered to being more and more electrical powered. And to bring the volatility on the demand side and the higher volatility on the power generation side at any time in balance, battery systems or large-scale ESS systems are needed to accelerate the energy transition. When we are, as Intellian, looking on the energy storage field, we always have in mind 3 pillars you have to fulfill to make the energy transition at the end really happen. First part is, of course, the hardware. We have the lithium cells to install in a certain cabinet, in a compartment, in a container, plus all the power electronics which are needed to run the systems, like the power conversion systems, the switch gears, the transformers, and so on. Then we have the second important pillar is then the software, who finally realize the application and fulfilling all the demands coming up from the energy management. And then we have, especially in these days, very important part is the fulfillment and service. So to execute the project, to install the system, and taking care on the operation of the system over a period of 10 to 15 years. If we now step into a little bit more detail on the hardware part, on the first pillar, you can see on the left-hand side and in the middle, C&I storage solutions. So for commercial and industrial end customers, here we provide the systems, which including, of course, the lithium-ion cells, the inverter technology, air conditioning systems, the energy management system is included. So it's finally a real plug-and-play solution. which we deliver, as I said, to industrial customers. The modular concept, so we have a wide range of energy content as well as output power available. And then for large scale business, for systems starting from 1 megawatt hour up to 100 megawatt hour or bigger, we have a different concept developed. So here we start with DC outdoor cabinets with an energy content of roughly 400 kilowatt hour. And for really big system, we implement the cells in 40 feet container, and then you can increase the number of containers to achieving higher energy contents. The second part, as I said, is then the software pillar. So starting with the battery management system, which are then integrated into the lithium-ion modules. All our systems are connected in a data cloud. So we are able to see the system behavior under certain environments. We also can do a certain kind of lifetime prediction and predictive maintenance service and so on. Then the second part on the right-hand side is then the customized solution. So the energy management system, which is programmed by a team we have here in Germany, and they taking care on the peak shaving algorithm or on the grid service algorithm and so on. And based on the data we collect out of the field from the installed base, we are quite aware of that there are also additional potential business model to use these storage devices more efficient in a long-term perspective over the whole operation time. Then the third pillar is then is the fulfillment in the service aspect. So we're starting very early into discussion with our customers to really understand their demand and creating the first concept, finalizing the design of the storage solution. Then we have partners in the background to do the assembly of the containers based on our IP and drawings and so on. And then we're taking care with an own team on installation and on the commissioning part of the project. And then it's important to run the system over their lifetime of 10 to 15 years. And this is also covered by the Intellion. And all in all, we also have a certain kind of dashboards and smart reports available for our customer, so that they also can see how the usage of the system was realized in the past. To give you two examples here, we have realized a project for a utility company. 10 40 feet container were installed in combination with all the power conversion systems, switching gear transformers and so on, 30 megawatt hour. And this is then in combination to a hydropower plant for grid stabilization function and also for backup power to the airport in Munich. And this was really a turnkey solution we realized in the beginning of the calendar year. Another example, not part of the utility segment, this is now an example out of the telecommunication world. So we also see that big telecommunication provider, which have huge data centers, I want to power their data centers with more green energy. And here we will install 60 megawatt hour on 3 data center sites in the next months, based on the modular concept I have shown before. And this is really then at the end also a turnkey solution we provide for this industry. And this is really exciting for us also to see that beside the C&I segment, so the industry segment and the utility segment, also the telecommunication world, think about powering their data centers with more green energy. And then as a final conclusion, we already have heard a lot about the market perspective and the fast growing market also in the stationary world. We also think that there is no other way around the battery storage system, which has to be installed into the grid to make the energy transition fast, reliable, and also sustainable. In these days, we trust in the lithium-ion technology. Nevertheless, we also think that the sodium-ion battery maybe in the future similar attractive in regards of performance and costs and so on. So we also look on the development of this technology. But at the end, it's not only to have the best cell in place, it's also a question how to bring the technology into an industrial project and how to integrate the cells into the electrical grid finally, and support the grid with the function which is needed. So therefore, we are looking also for more partners in Europe, and looking for the battery industry growing in Europe. So very exciting and very important for us also to have more players here in Europe. Thank you so much.
Thank you, Mr. Haubrock. Much appreciated. Let's have a look maybe at the poll question. All right, we see that 58% believe the market share is going to be equal, 26% believe it's going to be before the meter, now 30%, and 15% in front of the meter. Good. All right, let's move to the next presentation, which is from our EUROBAT member company Sunlight, and we have a representation by Mr. Gianpaolo Viane, who is the Chief Commercial Officer. Please go ahead, Gianpaolo. Thank you.
Thank you. Good afternoon. Can you hear me?
Yeah.
Okay. So I hope everything here in the technology works. Thanks for allowing me the time to speak into this presentation. Despite my role, I promise I will try not to go into any kind of commercial speech here, but give an overview of basically how an industrial model for producing competitively battery storage and the battery solutions can be set up in Europe, and also the several aspects of how this can fit into the demand of this market. So let me start with, let's see if this stuff works. Okay, excellent. So let me start with the outlook. So is there a market for battery storage? Yes, there is. There is a big one globally and in Europe. Everybody agrees on that. What you see here is a report which comes from research from BNEF and others. Quite everybody knows that the market is going to grow. But how is it going to develop? This is important to understand because it's all about the transformation of the prime mover of all of this battery storage, which is the electricity ecosystem. So our traditional transmission and distribution grids were designed decades ago around the central generation concept, and were based on fully dispatchable fossil fuel generation. As soon as the renewables started penetrating the energy mix, a need for remedying the sudden grid instability caused by them became contingent. And so traditional generation was found to be inadequate because disturbances were fast, very fast and many. So on-grid battery storage was introduced in some pioneering countries like USA and some European spots too, despite we were left behind thereafter, to remedy. And they slowly proved working. So the application spread out. This is called front-of-the-meter battery storage. Sorry to state the obvious, but it's not granted that most of the audience knows the difference between front-of-the-meter, behind-the-meter, commercial and industrial. But then new offenders to the grid stability came to the show. The house AC's consumption due to climate changes and electric vehicles fleet becoming significant in some countries. This requires more stabilizing solutions. And so the C&I residential storage started appearing and being deployed in some mature geographies. These are still battery systems, but they sit behind the meter. So their driver is for the user to save money on the electricity bill, avoiding peak tariffs. As we progress in the years to come, more renewable penetration will need more, of course, of front-of-the-meter solutions. And as this happens, we are going to evolve progressively towards a situation in which the demand side and the generation side of the overall electricity ecosystem are going to try to balance each other. So in the end, we come to the point where the electric vehicles, for instance, are on one hand an offender, potential offender for the grid stability, but on the other hand, they are also a balancing media through the grid, vehicle-to-grid application of storage. So kind of a virtuous circle. In between, there are 30 years. So this is the way it's going to evolve. The real question about that is how do we support this evolution going on? How do we make sure that European industry can actually support viable business cases for stationary battery storage projects? Well, we must be looking at two aspects of those projects: the capex, including how it is calculated, and the bankability of the project, which eventually boils down to how much of the risk is in control, okay? So the capex. One may argue that the Asian suppliers of lithium-ion batteries are way ahead of us and can offer unbeatable prices. True, if you only look at the ex-works equipment price. But if you start looking at the delivered price, you can see that the red columns grow significantly when you add the shipment cost, while the blue columns drop when you deduct the cells manufacturer margin from a vertically integrated DC battery block. Therefore, if you are a vertically integrated OEM manufacturing in Europe from the cells up to the complete DC block, you're actually 5% cheaper on the as-delivered product than the tier 1 Asian suppliers. This is without any policy action. But then, if you have a policy that fairly puts on the plate of the balance the greenhouse gas emissions associated with the full production cycle, you will end up with even more economical convenience of the European batteries, because you avoid all of the cells transportation, packaging, CO2 footprint cost, and also because the energy used to manufacture the cells in Europe would come from a mix that has low to no coal, while the mix in most of Asian countries still has a significant coal component, providing a huge burden of GHG emissions. All right, is it clicking? Yes, it is. Bankability, the second ingredient. This is the X-ray of a typical business case. Now, from the revenues, you deduct the net capex, the OPEX, the administrative costs, and then the outage. If you have unplanned outages totaling 45 days per year, there is no way you can break even. Even if you manage to collect your full 10% typical cap of LDs. Now, if you have a system failure in Europe and your supplier and OEM is in Europe, time to remedy will be few days to a week. But if your supplier and OEM are beyond the EU border, time to remedy will be weeks to months, and you easily end up into a loss. So banks, utilities, off-takers will, of course, care about this. So the conclusion is, viable projects are already there, as a matter of fact, because if, the Chinese sourced battery systems work already in business cases, for sure, also EU-made vertically integrated products will work in the same business cases. BESS will definitely work as a way to support the net zero target of Europe, as most of my colleagues have said already before. And there are fair ways to just value the local content with no need to necessarily enter into complex protectionist schemes like the IRA, which always have pros and cons, as you know. So, number one, award and penalize projects based on their total net greenhouse gases footprint, just as we already do for the CO2 emissions of the industrial production. Local manufactured batteries will deserve a good bonus. Retain the advanced innovation generated locally. Everybody's actually looking at the sodium ion today. I heard somebody talking about sodium ion. That's the future. Not everybody knows that sodium ion prototype technologies do not sit only the big battery companies in the Far East. We have labs in France, for instance, that promise very good products. But if they make agreements with non-EU industrial players to give them the technology, we lose a precious innovation content. Combined storage solutions, in which you mix up lithium and lithium electrochemical batteries and non-electrochemical long-term storage, so to optimize the cost of multi-hour storage solutions. This will never happen by individual initiative of privates. You need somebody, some policymaker, to support this kind of experiments. And finally, the addressable market size is also important. So instead of keeping on just pushing the electricity price from renewables down and paying crazy money to the fossil fuel pickers for a few hours operation to provide the ancillary services, why not to encourage renewables plus storage projects by having them paid back through access to the ancillary services market. So if I can click the next one. Said click next one. Click the next one. Okay, clicked. Now allow me just a little bit of a conclusion on Sunlight's vision. Now, this is our view of how to effectively shape the battery industry. And this is what we are doing, so to support an efficient transition to net zero of our countries. So from us, the industrial player, we need to take the initiative and integrate vertically the storage solution as much as possible, automating the cells production and remaining as chemistry agnostic as possible. We need to tighten the dialogue between the end users and the industry. The more they understand each other, these two players, the more the chances for new storage projects to actually become viable. From the regulator, we need you guys to deregulate the energy market and refocus regulation on the product market instead. Global CO2 footprint must be accounted for in any incentive penalty scheme. Also, the time is mature for the battery pack of the EVs to be no longer held by the EVs OEMs as a differentiator. There can be no optimum future for the EVs until the battery pack becomes what it has to be, a commodity. Like that, it's going to be easier to streamline the energy flows, control during the charging and discharging, plan them, and make sure the grid stays safe with no need for complex software and devices. And with that, if you please help me out with going to the next slide, because it doesn't work any longer. Thank you. And with that, I will just leave you with what Sunlight is doing now in this market. You can see that this is our plan to manufacture the cells locally. We have already completed our pilot plant successfully outside of Europe from our supplier of the full turnkey technology. Then we're going to install it here. We have the plant being already built. We expect to ramp up slowly from 2027 to 2029 up to 10 gigawatt hours production capacity. And then we can double basically this capacity in another couple of years. This is going to give us the cells production, and we're going to use those cells in order to integrate them into our range of products, so to have a vertically integrated product. And the next slide, please. And the range of product that we have is already there. So it's just ready to receive the missing local manufacturing of the cells. We have basically any kind of application from the grid scale, front of the meter, to the C&I, of course, to the residential. This is the first stage of our state-of-the-art production that we just launched in the last solar event in Munich. But again, we are looking forward to developing this further with that, integrate the cells production in which we believe, because we believe in the real possibility to have a competitive, effective enabler of the net zero targets in Europe for Europe. And with that, that's it. Thanks for your attention.
Thank you so much, Gianpaolo, for that presentation. And let's have a look at the results of the poll. So 64% does not believe that battery storage has been the most deployed energy storage technology so far, while 36% believes it is. Good. Next speaker I would like to announce is Jerry Bondwell. Jerry is Executive Vice President Sales at the EUROBAT member company Freyr. And I would leave the floor to you, Jerry. Thank you so much.
Thank you very much. Thank you for having me. So today I will speak about Freyr, why we are here today, and I will speak in different words what have been already said about how to maintain grid resiliency in a low CO2 electricity generation method landscape. So I'll talk about what is resiliency, why batteries, and what is our plan at Freyr. So first, what is resiliency? We know that the grid has to deliver reliable electricity to all their customers. So through different really key terms, it has to be reliable, meaning that the network has to be robust. It has to minimize disruption. It has to be providing a stable power supply, even in the most adverse condition. It has to provide redundancy, meaning that if there is an issue, an outage, there must be alternative pathways to provide the electricity to the users. We have to have in a grid fast recovery, meaning that if there is some disruption, the need for recovery procedure needs to be put in place, Response team needs to be ready to go. So very important factor to maintain this resiliency. And lastly, adaptability. We have to agree that it needs to be able to respond to rapid changing conditions, increased demand, weather event, or variation or variability of renewable energy method. So that's just to a little bit put the landscape. There are many other reasons why we need the resiliency in the grid, but that's a few of them. Then maybe I should answer why low CO2 electricity generation is needed. Of course, we all talk about mitigating climate change. We know that the climate change is caused by an excess emission of greenhouse gases. We know that CO2 is a major contributor to the greenhouse gases, and burning fossil fuel generates those excess of CO2, amongst other things. But that's one reason why we need low CO2 electricity generation. But there is also reducing air pollution. Fossil fuel-based electricity do not only emit CO2, but they also emit harmful air pollutant. If we look what have happened in China at the end of the 2000 years, the years 2000, the reason for going to EV was mostly to reduce air pollution rather than the climate change. That was a driver, in my opinion, of what have pushed China to push EV at first. Then we have to enhance energy security. With low CO2 electricity generation, they are most often, they rely on domestic content. Sun is local, wind is local, so there is less dependency on imported fossil fuels. And lastly, another reason why we need CO2 electricity is long-term sustainability. Fossil fuel, by essence, they are a finite resource, while CO2 emission CO2 electricity generation, low CO2 emission electricity method often rely on inexhaustible resources, sun, wind, and water, as we know them. So then, why energy storage is needed in this low CO2 emission context? So first, integration of intermittent renewable. By definition, intermittent renewable, solar, wind, are not smooth, they fluctuate. So having an energy storage connected to those renewable energy renewable energy generation remove this inherent fluctuation. It improves the grid reliability by allowing some more balancing between supply and demand. And there is a possibility to respond fast, help maintaining the grid frequency and the voltage within good limits. We have, with energy storage, the opportunity to manage peak loads. Of course, as that's the main usage of batteries, we need to charge in high demand and we charge in low demand, reducing the need in many countries that we see a business case, reducing the need for peaker plant. And of course, reducing the infrastructure cost by deferring some transmission costs. And that's the graph that probably we have seen earlier, and many of you have seen, is just showing that throughout the grid, from power station to users, there is different ways to monetize and to create value with battery energy storage. So the grid support from transmission to the user, there's always a possibility to reduce investments, so value creation for the system operators and transmission and distribution. Along the whole chain, there is a possibility to increase revenue by allowing some energy shifting throughout getting energy stored into batteries. And of course, for consumers, behind the meter, at customer services, we can see that as a cost saving. And what I wanted to show next is the example of North America. Today, most of the big projects are happening in North America. They are happening there because the technology has been demonstrated since quite a few years. And locally, they have found ways to monetize accurately the use of storage. And I will try to show here in two charts. What you see on the left is today's situation, a reference case in 2022. And the three next chart is a projection made by EIA in the US, trying to demonstrate that having standard batteries, it's the purple area at the bottom of the graph, or with having PV plus storage as a hybrid solar farm on the darker orange, that we are able to store the excess demand, which is above the dotted line, into batteries to be released later on. What has been interesting in the graph that we have seen many times is here is showing the layers of the different energy mix in the country, with the gray being coal, nuclear, wind, etc. What has been interesting in this evaluation, if you look at the gray area, the coal, there is a path toward eliminating coal through the use of storage. And that's throughout the US, not only in Texas and California, where we have most of the application today, but throughout the US, business cases made that we can eliminate fossil fuel into the energy mix under different scenarios. So I understand this projection, but in the past few years, what we have seen with energy storage, the large level of deployment is really possible, and it's really happening. So what we see is, what about Europe? So is there an opportunity as well to do similar activities in Europe? And if I take the two biggest countries that have deployed ESS today, UK is showing it's possible through the use of what we call ancillary services, having batteries deployed to support the reliability of the grid. And Italy is showing it's possible through the what we call the capacity market, meaning investing into long-term project or funding a long-term project that would provide PV integration into the grid by having a large storage area in the country. And we know that other countries that are coming online, but we really see that there are trends at country level, maybe not fully integrated into Europe because each country is still very independent and see different aspects of their need, but that's showing it's possible. So FREYR, who we are, what we do, I'll go very quick as well on this, we are a cell producer. We want to produce cells dedicated for LFP. We have chosen a technology, which is LFP. For the product, it's the same as what is known today, but we have chosen a simpler way of producing cells. We have chosen a way that is less energy intense by providing a process that prevents one of the most energy intense step in the process making. Some of you know, there is a step that relies on a solvent that needs to be evaporated, dried, and recuperated. And we are, with our process, avoiding this step. So we are at FREYR in the final stage of launching our product. We have, like I said, dedicated technology that allows us to have a cost-competitive solution made in Europe, but also made in US, Norway, in particular, and geographically in Europe, and in the US later, based on lithium-ion, dedicated by design to the ESS requirement and not necessarily for the EV. I think it's important for the customers and the market to know that they can get reliable supply on ESS dedicated product. So we have also created a joint venture with Nidec called Nidec Energy. Our cells will be fully integrated by Nidec Energy into a co-located production site in Norway. So we have launched a pilot plant, but it's not only a pilot plant. We call it CQP because it's multiple hundreds of megawatt hour that has been installed. The production line is ready to produce the first cells. And we are in the final stage of providing to customers the first cell from this giga, I should say, or very large pilot plant. And in parallel, we are building a 29 gigawatt hour factory next to it in Norway. And we are well advanced in the building of this factory. We are in the final phase of getting the final round of funding with hopefully some support from Europe or Norway to continue at full speed the deployment of this factory. We are in the final stage of getting the first product to customers. Our goal is to produce by mid-2025, both in Europe and in the US, where the IRA cannot be ignored. The IRA provide intensive subsidies to launch product over there. The market is there, so we will do a project in both factories, but really dedicated to this huge LFP market. So what I would say in conclusion, we need batteries in the context of a low CO2 grid. FREYR is committed to produce cells in Europe locally and in US to supply customers with their product and support the ambition of EU. We have a factory for large sampling phase being ready and soon full production. So that's what I wanted to exchange with you today. Thank you.
Thank you, Jerry, for sharing the FREYR vision on battery energy storage systems. So let's have a view on the poll. When it comes to the important reason for building ESS batteries in Europe, 65% believes it's for enhancing energy security, 30% for mitigation climate change, and 5% for stimulating economic growth. Good. And that brings us to our final speaker of the webinar. And I'd like to introduce Michael Lippert. He is the Director, Innovation and Solutions for Energy at Saft. Michael, the floor is yours. Thank you.
Yes, thank you very much, Gerd, for the nice introduction. Hello and good afternoon, everybody. Well, we at Saft, as you may know, are making batteries since more than 100 years. We are part of the Total Energies Group since 2016. And our ESS division, which I'm part of, is doing stationary energy storage systems since more than 10 years by now. And as you can see here, we have delivered or contracted worldwide more than 120 projects. So in order to open a little bit the perspective of today's debate, what I suggest as a last speaker is to bring some examples from around the world. Jerry has mentioned the US, so we will go rather east to show how energy storage tackles the issues of, let's say, renewable integration. Because we have seen the challenge is both, on the one hand, to balance demand and supply with a high amount of renewables, but also to address issues of grid stability or grid management in general. I'm talking about frequency stability, voltage stability, operational questions such as dispatching, feed-in management, capacity mechanisms, and supply restoration. So we will look at some smaller energy systems which nevertheless are facing these problems much earlier than some countries in Europe. So I first take you to Australia. This is an off-grid mine, a gold mine operated by Goldfields in Western Australia. And the challenge or the objective here is to maximize the use of renewables in an off-grid mining microgrid. What you can see in the picture in the background is an 18 megawatt wind farm plus a 4 megawatt photovoltaic power plant. And what you can see in the front is not the storage system. In fact, that's the original fossil or gas and diesel powered power plant. And the energy storage site is at the edge of this, consisting of some lithium-ion battery containers provided by Saft. And this is a 13 megawatt system, so quite powerful, but only 4.5 megawatt hours, so small energy. And why is that? Well, because what the battery does here, it provides spinning reserves. It provides the balancing power to compensate the variability of the wind and solar plant and to stabilize the grid in terms of frequency. This prevents the thermal engines to run idle and to consume power for nothing, basically. So if we look at how the operational profile looks, really, you see here the battery operation profile. So it buffers, it injects and absorbs power constantly from this microgrid. And in terms of results, since the very first days, and this system is operational since May 2020, the system achieved to have about 50 to 60% of renewable generation in its daily mix. The system is stable up to 85–90% of penetration in certain periods, and globally saves about 50,000 tons of CO2 per year. What does it mean for us from a European perspective? Well, a non-brainer. We have now demonstrated in many places that high penetration of variable renewables is feasible in the grid. The job to stabilize the grid under high renewable penetration conditions can be entirely done by battery-based spinning reserves, which substitute fossil-based reserves and balancing resources. Now, the driver of this I mean, besides CO2 savings and maybe some green image, which is important to the mind here as well, is essentially cost. It's economical factors, because you imagine the fuel in Australia is very expensive. So the cost of this spinning reserve is much higher with diesel generators than with a battery. But in other terms, it means that as long as the cost of conventional fossil-based balancing reserves is low, the business case for storage is difficult. And the cost of fossil-based or conventional balancing reserves may be really low in real terms, in particular for marginal cost can be low, but sometimes it's also artificially low because it's still subsidized or because it does not take into account external cost. I come to my second example, and we here go to Africa now, more precisely to Ivory Coast, which is a 2.2 gigawatt power system, and in which the electricity generation needs to double from now until 2030. Why is that? Because it is a growing economy and a very power-hungry economy in the future. And obviously, Ivory Coast relies on solar and wind to provide this growth. So we are now in Bundiali, which is a 40,000 inhabitants town in the north of Ivory Coast. And this is the first utility-scale, large-scale photovoltaic plant, which is implemented there, 37.5 megawatt. And it goes along with a 10 megawatt, 14 megawatt hour lithium-ion battery solution provided by Saft. And what the battery does here is capacity firming. What does this mean? It ensures that the power injected from the PV to the grid corresponds or is equal to the forecasted power in half-an-hour steps. So the battery is not big enough to shift power, let's say, from the day hours to evening hours. That's not the purpose. But it firms, which means it ensures that what is planned is really provided or delivered. So solar power is no more a fatal energy which can disappear. It is being counted now as base power in the system, and so it makes it as a reliable contributor to the system. So what can we learn from this? So as I said, solar PV energy under these conditions is considered as baseload generation. The firming requirement here is imposed by the Ivory Coast regulator. Of course, we can imagine different balancing strategies, more particularly on a national level, because if you aggregate different producers and aggregate balancing flexibilities, that may be more effective. Nevertheless, the point is that we know we do need balancing power for variable renewables. And we also know since latest last year that these reserves are not always available, and in particular that sometimes they can be very expensive, which leads me to my third point. We see in Europe that some IPPs start to use BESS in order to balance their own generation portfolio. They do not rely anymore on external balancing services, but they do balancing by themselves. My third and last example, we go back to Asia, is from Taiwan. And here we go one step further. Again, we have solar plus energy storage, but in this case, we provide both balancing service, or a shifting of energy solar from day to evening hours, and frequency reserves in a simultaneous way. So this is a larger system. It's a close to 60 megawatt hour and 20 megawatt peak storage system. And it does, as a priority, 20 megawatt of frequency regulation to the national grid. And in the same time, some load shifting of the solar power plant, because obviously energy is usually abundant in the afternoon and more critical in the evening hours. This is how it looks like. If you look at the right-hand side, upper graph in blue, well, this is the typical national frequency regulation profile, which is combined with the second one, which is the PV shifting profile. So in peak production hours, the battery will absorb excess solar power and it will re-inject the solar power in the evening. So the third graph shows you the combined power, which means that globally, in periods of high production, high frequency, the battery in sum absorbs power from the grid, but continues to follow the frequency regulation signal. And inversely, in periods of low generation and low frequency, it does inject power to the grid. It shows that we do have the possibility to combine multiple services simultaneously or in sequence on the same battery. This is technical, but my message here is we do need to do this in order to have an economic optimum. We do need to use the battery in the most optimum way and to do as many services as it can in order to decrease the individual cost for a given service. It's like a taxi. Obviously, if you transport 3 people in a given taxi, that is less expensive per passenger than if you only transport 1 passenger by the same taxi. And so this cumulative services model for batteries is necessary in order to make battery energy storage an economically viable and competitive solution. Now, obviously, my third point, in areas where we have vertically integrated utilities, this is quite automatic. It's a non-brainer because the benefit of storage for both balancing supply and demand and for ancillary services is obvious and can be integrated by the same operator. This is not the case, as you know, in Europe, because our regulation system and market design still makes it quite difficult to realize this, say, technical and economic optimization in the same time, as we are obliged to separate energy services and grid services by regulation and by our current market design. Well, that's it for me for today. Thank you for listening and thanks for questions.
Thank you so much, Michael, for sharing the SAFT angle. Before we move to the Q&A session, maybe a quick glance at our last results of the poll question. So it seemed that over 70% of the respondents indeed agree that BESS for a large standalone project can indeed be deployed in less than 1 year, and for behind the meter even in a number of days. Good. Conscious of time, Bernard, we should indeed move to the panel discussion, which will be managed by yourself. As said in the beginning, we can only have time to address the most pertinent questions. So I would say shoot. Thank you.
Thank you, Gerd. Thank you, everybody, for this very interesting presentation from my side. And right away, I have to apologize. We have really to select from these various and diverse questions the most relevant ones. And I think I start with the first question with Ilka. Ilka, one question which is very important is, on the one hand, the higher raw material prices and other supply chain constraints have hindered the investments on BESS. Do you think, or are policies like the European Net Zero Industry Act and the US Inflation Reduction Act going to help, from your perspective, meeting the demand expectation for energy storage?
I think, in fact, they will, especially the Critical Raw Materials Act. In many cases, it's the lengthy permitting times that we have around European development of mining projects. They will be shortened, hopefully, once the Critical Raw Material Act is adopted. So I think this will also give certainties to investors to actually follow through with projects and thereby helping them bring on the market for the materials. Together with US IRA, I think also we will see a lot more international projects coming online. Hopefully here the US and Europe will work together, because it's the resources that will be needed by both of our markets. We are both competitors, but also cooperation possibilities in a global market like this.
So thank you very much, Ilka. And the next question I would like to address to Ida. Ida, one most relevant question is, on the one hand, did Europe's Repower Europe plan, which was launched already in 2020, provides already significant measurable boost in clean tech sales within the energy sector? Do you see this already?
Definitely. I mean, Repower EU, it sets a very good direction for clean electrification. That's for sure. It's not only about the targets that we were discussing earlier. It's also about the framework for mandated accelerated permitting. It sets also a vision for doubling heat pumps and indirect electrification through electrolytic hydrogen. And that's of course very much welcome. It's a very good basis, but from now till 2030, there's a lot more work to do in order to bring both those variable renewables and the new electrified consumers into the grid. Going forward, definitely there's a need to maintain, to secure regulatory certainty. It seems as a given, but what we've seen in the last couple of years, it's unfortunately quite detrimental for the investment in clean technologies. But also, apart from this regulatory visibility, this should be followed or in parallel with investing into new grids, into new storage, boosting this flexibility that we need for the integration of clean technologies.
Thank you very much. And I go on, I think, with André. André, concerning now the battery regulation, what do you expect from the new battery regulation? Will it help Europe, and what bottlenecks can it serve or solve?
So the battery regulation will, of course, help to improve further and to define a common agreement of rules. And so especially when we are talking about the CO2 footprint, which has to be fulfilled, and also the production framework, which has to be followed regarding also low waste to be created. Battery health will be monitoring based on the battery regulation, and also the recycling aspect, I think, is very important in long term. So to keep the raw materials in the European region. So it definitely helps, but I think it's not the full story at the end. We also need at the end a competitive battery industry and a sufficient and efficient supply chain for all the battery suppliers and system integrators finally. But as I said, it will help, but it's not the full story to make the things at the end successful.
So thank you very much. I go over Gianpaolo. I have seen the strategy from Sunlight, but on the other hand, there is a question directly to the strategy. What are key enablers needed for battery energy solutions deployment at a scale?
Yeah, I think as you said, most of the ingredients are there. In my opinion, the first thing that is needed is really trying to open up the market for the battery storage application, because the more you regulate in this kind of ecosystem, which is the electricity ecosystem, the less you have adaptation of the resources. A very important thing is really in those places where renewables are not allowed access to the ancillary services market in the short term. This is needed, because if you let them access the ancillary services market through the use of storage, this is going to improve significantly the IRR of most of the business cases. And at the same time, I think one very, very important thing is really to keep investing into the development of new chemistries and new technologies inside of Europe, with a strong incentive to keep them in Europe when they get industrialized.
Thank you very much. I go on, Jerry. What is the main barrier to battery energy storage deployment today? What do you think? Policy, cost, technology, maturity, or do you have other aspects on the deployment of battery energy storage systems?
Yeah, certainly the technology is mature now. It has been demonstrated since quite a few years now from some of the companies around the table, but also in the market in Australia with very large project, in the US with very large deployment and a pipeline of multiple gigawatt hour. So the technology is mature, particularly with LFP cells now that have demonstrated that they can provide the right service. Cost, we also have demonstrated, thanks to the progress in particularly in the PV world, it's now demonstrated that the cost generation from PV is very low. When we add the storage, the solution remain competitive more and more. It has been demonstrated in many countries that we can eliminate the gas peaker plant. So those two, cost and technology maturity, certainly not the major barrier. Policy, yes, one could say policy, it's still country by country, very, very delicate. It can be deployed in some country and not others. I think naturally the policy will adapt. We saw some graph earlier showing that there is an absolute need for low CO2 emission. So those can only be deployed at scale with energy storage. So I think common sense will prevail, and at some point the policy will be adapted. We hope sooner than later. But some countries like the UK have opened up some policies, and others can follow suit.
Thank you very much, Jerry. Michael, the next one would be addressed to you. What positive examples of sound policies can be followed in Europe to enable battery energy storage?
Well, I mean, globally speaking, if you want to decarbonize the system, you should give an advantage to low or zero emission solutions. So for what concerns Europe, when we're talking about capacity markets or ancillary services markets, for example, the installation of a CO2 cap to these technologies would certainly help. I mean, we cannot take the example of a fully vertically integrated or nationalized energy systems where just from top down people decide that this is the way to go and they make the investment decisions. But if you're thinking in European terms, so CO2 caps could be a solution. Other than this, and again, compared to the examples I've been given, of course, I think that we would have deployed storage faster and earlier and much more today if TSOs, so transmission and distribution system operators and utilities in general, were able to own and operate storage systems for multiple services. This is not the case. We cannot probably come back to this. I will not revolutionize the system, but a solution to this, and in particular also to open up the market and to address certain upcoming markets and technical challenges that we will see increasingly when we will have 70% of variable renewables or renewables on the grid, is to think now about a harmonized definition of and remuneration scheme for different grid services. So to define them, to implement them Europe-wide, and then by this to also to give a visibility to investors on what kind of services we will need, how they will be implemented, and how they will be remunerated in Europe. So this is to, let's say, to overcome the handicap we have, again, from our perspective, of course, that we do not have a simple vertically integrated power system, but a deregulated, market-based system.
Thank you very much, Michael. Ilka, I would like to continue with you, especially concerning your presentation. You have mentioned you see a similar growth for battery energy storage systems like in the EV market. On the one hand, we know what kind of production capacities are planned in Europe. On the other hand, we want to be somehow independent. do you think we will match this growth for battery energy storage system and EV in the time frame?
I think the growth rates are one thing, the volumes are another, and I think from all the presentations that we heard from Freya, from Intellion, from Sunlight, they all see a market, and they have projects that are coming online in Europe, which is very promising. I think in terms of volume, of course, it's not comparable to the EV system, but similar to the EV system, and I think there the industry still needs some policy support to actually get projects off the ground and growing. I know that Gian Paolo said they're already competitive, but if this would really be truly the case, I think we would see a much more rapid and accelerated growth, and not currently seeing a lot of investments going westwards to the US or other regions in Asia, where I think they believe still is a more attractive business case to get. So I think Europe still has to be on its toes and continue to support the battery industry, really to create this resilient grid as well, because we need batteries in all different parts of the system.
Thank you very much, Ilka. Then I come back. Ida, perhaps you have shown us perhaps also different technologies which are used for energy storage solution. Do you see some constraints concerning battery energy storage, concerning different application and the duration of storage time? Do you see here preferred technologies?
As Eurelectric, we are technology neutral. We let the market to decide what's the most cost-efficient technology and the most suitable, compared to the most suitable capabilities. So as Eurelectric, we cannot pick a winner. In any case, there's a market for everybody. As you've seen in my slides, we need all the technologies to overcome the challenge, from hydropower, from pumped hydro to BESS, also long-term duration storage, and other sorts of seasonal technologies. But yeah, I think there's enough space for everybody.
Then I will give one question, I think, to the rest of you, my colleagues from the battery manufacturers, especially concerning technology. We heard from everybody, mainly the preferred technology right now will be the LFP technology. We hear something from sodium ion as an upcoming technology, new technology, which is very promising. But do you consider, and we as EUROBAT consider always also mainstream technology which are established over years? They have a circular economy already established and have still, in our opinion, improvement potential for certain services. Do you see here any chances also for funding and also support to install such kind of system? So I start with André, and then I would go through the same procedure like before. What is your opinion, André?
So my opinion is that funding, of course, will help, but I didn't get the question. Bernard, can you repeat it? Because I had some concerns.
Yes, again, we discussed now LFP as a main technology, I think, for large or battery energy storage system right now. Upcoming technology, perhaps as a promising technology, sodium ion. Besides this, we have mainstream technology, which are lead-based or nickel-based technology, which have proven in the last decades that they could be improved always for certain application. And why we are not considering such kind of technology, especially under the situation that we need fast installation, and we have here also not the situation with critical raw material in some issues.
So I think at the end it's a question of pricing, of performance, of cycle behavior. and of availability. So I would agree that in certain application, of course, lead acid and also maybe nickel technology makes sense to install. And here and there, we also see some hybrid systems to be installed due to the different load profiles which has to be covered. But at the end, we would say, okay, in these days, it's the lithium-ion technology which fulfill most of the demands in a best way. But I'm quite sure that in a midterm perspective, other technologies, and we also see within the lithium-ion technology fast developments on the different on different material sides, and therefore also a performance and a price improvement.
Paolo, what is your thought about it as somebody who offers also different technologies?
Look, as I mentioned before, 5 years ago, 6 years ago, the battery storage, lithium-based battery storage was the NMC. Nobody was considering LFP, despite it was there. Then 5 years after, NMC has been killed in any stationary storage application, LFP is ruling. So, and the evolution continues. Now we talk about sodium ion. So it is not excluded that within the mix, you can also blend technologies that already exist. I mentioned one new, which has not been talked about, which is the flow batteries. The flow batteries are big stuff. It's already there, fully available. We know the technology. The figures of that technology are proven and consolidated. We know the round trip efficiency, we know cost, and so on and so forth. As soon as stationary storage application exceeding 6-7 hours are going to become really viable, flow batteries are gonna be applied right away. And so there will be also chances to, you know, cash back into the game already consolidated technologies like lead acid, as Andre said, in some kind of hybrid configuration. So my view is really today it's lithium. It's completely wrong considering that lithium is going to continue to, you know, draw the way for the next 20 years. This is wrong. New things are going to come up, and we need to be able to catch the advantage of the several things, including the hybridization of several different storage chemistry, still battery chemistry.
Thank you. Jerry, I hand over to you.
You know, I have a long background in the other technology, so my view is for ESS, the market, like you just said, the market has moved to LFP for cost, for performance, for life, for cyclability. So it's what the market have decided to go to because of those the main attributes on those key factors. Lead acid batteries, I know them since 25 years. They are probably the best product for application where there is constant overcharge. There is a backup we need once in a while to discharge. It's a super robust system, no doubt about it. Every time we talk about heavy cycling and weight constraints, space constraints, then lithium-ion become the best solution. But there is application for all, I'm convinced. It's just that today, I'm interested in lithium-ion because a market for energy storage is massive. The market have decided now to use LFP. Yes, here we are open. We are looking carefully at what could be the next generation. But that's today a market decision in a sense. So we want to fulfill that market requirement, which is massive and much bigger than what other technology can provide today.
Thank you very much, Jerry. Now, Michael, you, the last one. I would like to hear your opinion.
Not very much to add. I agree with Jerry and Andre. It's a question of price performance globally. So if you and there is space for everybody to give you the political answer, but also with regards to support schemes and investment in R&D. If you demonstrate that by investing further innovation into this technology, you can achieve certain price or competitive or performance levels, at least in certain maybe applications or niches. Or on the other way around, if you are not able to demonstrate this, and if you say, well, we can improve, but nevertheless, we will always stay this much below in terms of performance, other technologies, of course, then that's a no-go. Now, for what concerns lead acid batteries, maybe a way to go is in particular to try to combine the advantages and market applications of incumbent market segments, so where you are strong and where there is a reason, as Jerry said, and to reach out and try to combine this with, let's say, more grid services or other applications. So this could be maybe a way to go for in particular lead-acid batteries.
Thank you very much, all of you. I think we are over time. Thank you. Sorry that we couldn't, prioritize every question. We have a lot of questions. Thank you, everybody. I would conclude, we need battery energy storage systems. The preferred technology is at the moment the LFP technology. I think we have to see how we solve the demand in the future with LFP, and we have potential for all other electrochemical systems. There are potential new systems which are upcoming, and also mainstream technology. They can prove or even provide special services in the stationary sector. Thank you very much.